AI can unlock enormous value from enterprise data, but only when that data is classified, protected, and governed correctly. In this topic, we'll connect privacy by design with compliance-ready Azure AI architecture. We've moved from TOGAF foundations through the ADM and into Azure architecture for enterprise AI. Now the focus narrows to the data itself. Before AI platforms can be trusted, their data must be classified, protected, governed, and aligned with policy, regulation, and enterprise risk expectations. Enterprise AI is powerful because it connects data, models, users, and decisions. That same connection is why privacy matters. If sensitive data is not identified early, it can surface through prompts, embeddings, logs, or outputs, creating legal, security, ethical, and reputational risk. Data classification gives teams a shared language for risk. Public data is already approved for external use, so controls are lighter. Internal data stays within the organization or trusted partners, because misuse could create operational or reputational issues. Confidential data carries real business sensitivity, such as customer records, contracts, pricing, or financials, and needs stronger access control, logging, and governance. Restricted data is the highest concern. Regulated, highly sensitive, or mission-critical information like PII, health data, payment data, credentials, legal records, or core intellectual property. The rule is simple. As sensitivity rises, handling requirements rise too. In AI platforms, sensitive data is not one single category. Personally identifiable information such as names, emails, and employee IDs creates privacy obligations. Financial data, including account numbers, invoices, and forecasts, can create payment, audit, and market disclosure risk. Health and biometric data often carry stricter consent and retention rules. Intellectual property, such as source code, designs, algorithms, and strategy, may not be privacy data, but it can be business critical. The key mental model is this: classify data by the obligations it triggers, then design controls, access, logging, masking, and retention around that category. Classification only matters when it changes behavior. A public dataset can be shared broadly, but its accuracy and appropriate use still need protection. Confidential data raises the bar with approved access, encryption, monitoring, and controlled sharing. Restricted data requires the strongest controls: least privilege, strong encryption, audit trails, data loss prevention, and short retention windows. For AI, apply the same logic beyond source data. Prompts, training sets, embeddings, outputs, logs, and human review notes all inherit handling rules from the data they contain or expose. That keeps collection, storage, transmission, and deletion aligned with business risk. Protection starts before an AI system ever sees the data. First, scan the estate. Azure SQL, Data Lake, blob storage, Microsoft 365, APIs, and analytics platforms. Then classify what is found, such as personal, confidential, regulated, or business-critical information. Labels and metadata turn that classification into action through access decisions, encryption, retention, monitoring, and policy enforcement. Microsoft Purview helps connect the process with cataloging, lineage, sensitivity labels, and governance workflows. The goal is continuous control, so every new AI data source is discovered and governed instead of quietly bypassing compliance. Privacy by design means privacy is part of the foundation, not a feature added at the end. For AI architecture, it starts with requirements and continues through design, deployment, and operations. Data minimization asks, what data is truly needed for this approved purpose? Purpose limitation asks, can this data be used here, or was it collected for something else? Privacy controls then enforce consent, access, retention, anonymization, and secure handling. Finally, transparency and auditability make the system explainable and reviewable across ingestion, processing, inference, and outputs. A trusted AI platform is built by making these controls structural from day one. Before personal or regulated data enters an AI workflow, follow a simple decision path. Identify the data. Confirm the lawful basis for processing, such as consent, contract, legal duty, legitimate interest, or another permitted basis. Clarify the exact approved purpose. Then check whether consent, policy, or regulation allows this new use, especially for training, analytics, or personalization? If the answer is no, block it. If the answer is yes, still apply safeguards like minimization, masking, and retention limits. The architecture must also support data rights, so people can access, correct, delete, restrict, or object when the law requires it. Data minimization begins with one practical question. Does the AI system truly need this data to deliver the approved use case? If not, leave it out. That applies to source fields, prompts, context windows, training sets, embeddings, logs, and backups. Retention is the second control. Decide how long each class of data is kept based on regulation, legal hold, and operational need. Then automate deletion, archival, or anonymization. The goal is not just privacy. Less data means lower exposure, lower storage cost, simpler compliance, and fewer surprises during an incident. Sensitive data can be transformed before it reaches an AI system. Anonymization is the strongest claim. Identifiers are removed so re-identification is not reasonably possible. Pseudonymization is different. It replaces identities with tokens or aliases, but someone with the right lookup table or extra data can reverse the link. De-identification is the broader toolbox. Masking fields, tokenizing values, aggregating records, hashing, redacting, or generating synthetic data. The key architectural question is residual risk, especially when datasets, embeddings, logs, or outputs can be combined. Privacy controls are only defensible when access is observable end-to-end. Every touchpoint should generate evidence. Sensitive datasets, prompts, outputs, vector stores, model endpoints, admin tools, and approvals. Identity from Entra ID, least privilege, and RBAC help show that access decisions were appropriate, not accidental. Monitoring then looks for warning signs, such as bulk downloads, unusual queries, privilege escalation, or unauthorized exports. Those logs feed tools like Azure Monitor, Sentinel, and Defender for Cloud, and are retained for audits, investigations, and governance review. Compliance frameworks become real when architects translate them into design requirements, operational controls, and auditable evidence. GDPR drives privacy by design, minimization, consent, subject rights, breach handling, and transfer safeguards. ISO 27001 emphasizes risk management, control ownership, monitoring, and continual improvement. SOC 2 asks whether security, availability, confidentiality, integrity, and privacy are operating effectively. Industry rules add more context, such as HIPAA, PCI, finance, public sector, or residency needs. The goal is one control model that satisfies many obligations, with evidence generated continuously. To make that control model repeatable, build compliance into governance checkpoints. Regulations such as GDPR or HIPAA are translated into architecture requirements, principles, and measurable acceptance criteria. Those principles guide design choices like data minimization, least privilege, secure defaults, and auditable access. As solutions move through design, build, deploy, and review, teams capture evidence that controls were implemented. Governance checkpoints then test classification, privacy impact, security, compliance evidence, and residual risk. The result is traceability from obligation to decision to control, making compliance easier to review, repeat, and govern across projects. The main takeaway is that enterprise AI architecture must treat data governance as a design responsibility, not an afterthought. Classify sensitive data first, apply privacy controls by default, map regulations into concrete safeguards, and capture evidence as you build. With that foundation, you are ready to move into responsible AI governance and formal threat modeling.